base is not e. It is some other constant that we're going to call a. What is one way we can turn an exponential function into an algebraic function? Matthew.
We take the log of both sides.
Which log?
Natural.
Yes, we natural log both sides. Because when you natural log it, what can we do with the x? Boom. Drop it down, right? Okay, now we can do the derivative. What's the derivative of the natural log of y?
1 over y.
1 over y times y primed, or y primed over y, or dy di, or whatever you want to call it. I'm just going to say y primed over y. What is the derivative of x natural log of a? Remember, a is a constant. X natural log of a.
Oh, it's 0.
No, you said 0. It's 1.
What's 1? What's the derivative of x natural log a?
1 over 0.
What's the derivative of 2x?
2.
What's the derivative of x natural log of 2?
What? 2.
0.
Oh, 0.
If you did the derivative of x natural log of 2, it would just be the natural log of 2, right?
What?
Natural log of 2 is a number. It's a constant, right? So if I said the derivative of 2x, that's just 2, the constant. If I rewrite the constant as natural log of 2, it's still just, natural log of 2. Okay? Because it's a constant, right? So this side is just the natural log of a.
What happened to the x? It's
Look at it as like
A
2x. Just write it. Look at it.
Just look at it as AX.
Yeah, ax.
So it's just A?
Yeah.
Okay. Now, how do I get y primed?
Bring the y.
Multiply it up, right? So y primed is equal to y ln of a. What is y? Ax. So the derivative is a to the x times the natural log of a. That is a formula you can remember if you really want to. I don't. I just log both sides. Now, if we did it with u, okay, hang on, let's just derive this formula. What do you think? Y is equal to a to the power of u. U is some function of x. Okay? So, natural log of y, you're going to do the exact same thing to drop down the u. All right, here we go. What is the derivative of natural log of y? Okay, peoples. What is the derivative of u ln of a? There you go. Because u is some function of x, right? Or du dx, whatever you want to call it. Doesn't matter. So if we multiply the y up, which is our original function, we get the derivative is a to the u times u primed times the natural log of a. I do not remember these formulas. Okay, but those are the formulas for deriving a base other than e, an exponential function with a base other than e. So just for example, we'll do one example. We'll start with number what? 1? Seems like a good number. If I said take the derivative of, I don't know, 2 to the, we'll just do something simple, 2 to the x. You could use the formula. The formula says it'll be a to the x, 2 to the x, times the natural log of the base, which is, that's the derivative. Okay? That's according to the formula. If we made the exponent more complicated, so I said, I'm going to show you another way to do it. 2 to the cos x. We'd have to use the u one, right? Because cosine has a derivative that's not 1, right? Whereas this has a derivative of 1. So we're going to go a to the u, the actual function, which is just 2 to the cos x, times u primed, which is what? What's the derivative of cosine? Negative sine of x, times ln of the base, and the base is 2. It's just natural log of 2. Okay? If you remember the formula, you can do it that way. I don't like the formula. I find it clunky. Unless you're going to use it multiple times. All right? Sorry? Yeah, that's what we're going to do right now. Yeah. The way I would do it is I would do this. We'll do the 2 cos x one. I would go, okay, I'm going to say y is equal to 2 to the power of cos x. Okay? And then I would natural log both sides. And that will bring down the exponent like that. What's the derivative of natural log of y? Y primed over y. Remember, natural log of 2 is a constant, right? So what's the derivative of the right-hand side? What's the only thing that's going to change here? What's the derivative of cosine? It's going to be negative sine of x times natural log of 2, right? Everybody with me? Okay. You multiply the y up. The y was this, the original. So you get y primed is equal to 2 cos x times negative sine x times the natural log of 2, which is that. Just log both sides. That's what I would remember. Okay? Just log both sides.
What happened from there?
Then you took the derivative. Okay, let's do another one. We got about 12 minutes left. We'll just do another example, a couple examples. So this allows us to solve funky, weird functions. So we can do something like this. Y is equal to x to the power of x. This is an exponential function. It's a weird function, but it's an exponential function. Okay, because you have a variable in the exponent. But we don't want to deal with that. We want to get rid of that exponent. How do you get rid of exponents? You log both sides. Natural log of y. If I log this side, I'm going to get x natural log of x. What? I don't know what it is. I just made it up. Yeah. Okay, what's the derivative of the left side? Y primed over y. All right, we got that. Y primed over y. The right side, we have to use product rule. Product rule says derivative of the first function. What's the derivative of x? 1 times the other function. Plus, what's the derivative of the natural log? 1 over x times the other function, which is x. We can clean that up. So I'm going to get natural log of x plus 1. Right? Because the x's will just cancel that bit right there. Okay. Then you multiply the y up, which is x to the x. and you get y primed is equal to x to the x times the natural log of x plus 1. Yeah. Why what? Sorry? Why do we have to use product rule? Because you have two functions being multiplied together. Okay? All right. Let's do one last one. Won't make it too hard. What do? We should do y is equal to 7 to the power of 3x squared plus 1. Go. And we'll see if we meet at the end. You can use the formula or you can just log it, your choice. Are we ready? If you log it, it's like everything else we've done. That it? 7, 3 to the 3x, 7 to the power of 3x squared plus 1 times 6x times the natural log of the base, or of 7, the base. Yeah? Okay, one last one before the end of the day. Let's do... There you go. We get it? You can add the e to the x's together because they're the same base, right? So x plus x would just be 2x. If you wrote this one here, this is right. But e to the x times e to the x is e to the 2x. Just add the exponents.
Wait, how come it's 4e? Why is the e x down?
What?
Why is the 4? Yeah, why is the e down? Why isn't it up?
Oh, shoot. I wrote it wrong. I don't know why I did that. Thank you. It's 4 to the power of e, right? I messed everybody up there. There. That's it. There you go. Sorry, my mistake. All right. Are we good? Okay, we're going to call it there. Tomorrow we'll pick this up. We'll do the integration stuff.